Hello there, today we'll be doing multiples of 3 and 5. So we're looking to get a multiple to sum up all the multiples of 3 and 5 below 10, and that would give us 23, because if you look at all the numbers from 0 through all the way below 10, we would have 3, 5, 6, and 9, and that will total to 23. Okay, so we'll be using the umpire method for this. And let's understand the problem a little bit. So to understand, we'll be adding all numbers from 0 to 10 to up until 10, all numbers that are multiple of 3 or 5. Are there any questions about this? Let's make a couple test cases. So one test case is input. We expect an input of 10 to give us an output of 23. Are there any inputs like 0? No. Well, anything input of 0 should give us an output of 0. What about negative numbers? I think edge case, like let's say input is -1, I think we should return an error. So anything else? I expect a runtime of O of n, because we'll be going through n numbers, and we expect a space complexity of O of 1, because we'll be using one item to store all the sums. Alright, so let's move on to our method, match, which is going to be a looping. Of course, this is to learn about recursion, so we'll be converting to recursion after that. Alright, with that, let's make a plan, and the plan is exactly as I said earlier, to add all numbers that are multiple of 3 and 5 to up until 10. So let's implement it. So first things, define the function, and the function is called add all nums, all multiples of 3 and 5 till num, and that's going to return our sum. So let's set a total equals 0, so for I in range of num, and we're going to if I modulus 3 is equal to 0, or I modulus 5 is equal to 0, then they are multiples, so the total is going to be plus equals that I number. At the end of this, we're going to return our total. And now we review. So we expect an input of 10 to return 23. And I expect this to be correct. So we could either run it till 10 and print this out, or we can just go through it by hand as well. So to go through it by hand, let's set I equals 0. We start at 0, and the total equals 0 at this point. And now that I is 0, nothing happens. I is now 1, nothing happens. 2, 3, 3 is gets us to 3. 4, nothing. 5 would get us to 8, and 6 is a modulus 3 is 0, so that's going to be 14. 7 is going to be nothing, 8 is going to be nothing, and then 9 is going to be 23, and give us a 23, and that's where we'll end the loop, and we'll return 23. So with that, let's print this solution. And suppose we try 1,000. That's going to be our answer. which is approved here in Euler's. So another thing, as are evaluated, we will be going through the entirety of these items, and lastly, the space is going to be O of 1. However, if we do this in recursion, we'll run into a maximum number of recursions that we can make when we reach about 100 or so. I mean, we can make it past 1,000. But let's define the recursion way of doing this. So this is pretty simple. We take the recursion and we put in the num. And what's going to happen is we return an int. So let's talk about the base case. If num equals to 0, that means we're going to return 0. Otherwise, if the number is modulus 3 is equal to 0, or num modulus 5 is equal to 0, then that means we're going to return num plus the recursion of num minus 1. Otherwise, we'll just return recursion of num minus 1. With that, we are good to go, and we can just return a recursion of 10, let's say. And this would give us, oh, not 10, of our num. Of course, we can do 10. Well, actually, we do need a num minus 1 because we're going 2. So now it's 23. And we can try to get 1,000. We try to get 100, but that would fail. Because, oh, actually, it's not failing right now. Let's try 200. Let's see when it fails. Oh, it's not failing at 200. Okay, let's see 1,000 then. Okay, so it fails. Let's try 300. Let's see if it fails at 300. I think it's 256. I believe it's oh, no, it's not 256. 400 then. Okay, 999. Is that it? Is that it? No. Okay, I guess I should do binary search. That would split these in half. So 750 is good. Let's go 825 then. Let's go 950. Let's go 989. Let's go 999. 998. Okay, we're getting close. 990. Hopefully I'm not wasting anybody's time, but we're just testing where the limits are. 995, 996, 996. Nope, 997 should be it. That should be it. 998. Yeah, 998's the one that's the limit of the number of times we can do recursion. Okay, so with that, we have converted this to recursion. And if you enjoyed this video, like and subscribe. With more videos, check the link in the description below. If you have any questions, please comment in the video, and I'll see you in the next one. Thank you. Bye.